Hello and welcome to another one of these ADD videos. Today we're going to be looking at composite function examples. So just a quick recap. FOG means f of g of x, which means take your g of x function and plug it in for every x you see in the f of x function. And the domain would be the domain of g of x and the final answer, the one you plug in and the final answer. So these are both polynomials, so odds are you're going to get domain of all real numbers for this one. So let's look at it in action. I'm going to do different colors so you can actually visualize what's going on here. So this one right here would be f of g of x. Sorry, I guess I should write f of g of x, which is fog in this case. And your g of x is 2x plus 3. So in every scenario that there's an x in the parent function, we plug in the 2x plus 3. And in this case, the parent function, is f of x and should be green. Okay, so that's it visualized. So I'm going to go to one color now. Here you're going to FOIL this out. You can use the box method, write them out, FOIL it out, whatever you want to do. My shortcut is square the first one, square the last one, and then twice the product. And then distribute the two through. And then at that point, combine your like terms and you're done. Alright, and the domain of this answer is a polynomial, so it's all real numbers, and the g of x we plugged in was another polynomial, so it's all real numbers as well, so this would be the domain here. Alright, let's look at this next example. We've got f of x is that, and we want to plug in g of x. Ooh, I think I did this backwards. I wanted you guys to do g of f of x. Sorry, that was my fault. So that means we're going to plug in f of x everywhere we see an x in g of x. So g of x is 1 over x squared. I guess I could use colors for you. The parent function is g of x, so we have 1 over, and then instead we plug in f of x instead of the x that's on the bottom. We get that right there. And in this case, the domain would be the domain of your answer, which in this case we know the denominator cannot equal 0. So x cannot equal plus or minus 3. And then the f of x was a polynomial. There are no denominators, no square roots, so we have a domain of all real numbers. So how do we combine not equal to plus or minus 3 in all real numbers? Well, the only restriction we have here is the plus or minus 3, so we would go from negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. Alright? There's your domain right there, and there's your composite function. One last one. This one's going to be a little bit more challenging. Here we have two functions. I'm just going to do it in red this time. So if we're doing g of f of x, actually I'll use colors. So we got f of x being plugged into g of x, so we've got the square root of x plus 9 over the square root of x plus 9, and technically that line should be in orange because the parent function is orange, g of x. And that's going to be squared minus 18. When you square something, you're going to get itself underneath the radical. So you're going to have the square root of x plus 9 over x plus 9 minus 18. I should have raised it to the fourth power. So then at this point you get x minus 9 in the denominator. So it's going to be x plus 9 square rooted over x minus 9. So your domain in this one has two parts. It's going to say x plus 9, the square root part, has to be greater than or equal to 0. So x is greater than or equal to negative 9. But this denominator can never equal 0, so x cannot equal 9. So the way you would combine both of those, easiest way is to draw a number line. And we would draw an open dot for 9 and a closed dot at negative 9. And this says greater than, so that's to the right, but we can't include that 9 there. So your domain would be negative 9 to 9 union 9 to infinity. Okay? So you can see these are, oops, this should be bracket, sorry about that, because it's including because of that equal sign. You can see they can get a little tricky, but if you practice them, you should be just fine. Hope I've cleared up any confusion that you might have. Thank you and have a nice day.